Hello, I'm Eric Snodgrass, and thank you for watching this Friday morning in-depth ag forecast brought to you by Nutrien Ag Solutions. I'm coming to you about 12 hours later than I normally do, largely because I was stuck in North Carolina for an extra 6 hours last night. I live right here in Champaign, Illinois, just outside of it, and so flew from Chicago, got in about 6 hours late, which meant I didn't get home till almost 4 in the morning. So I just didn't have a chance last night to record. I thought about entertaining some folks while I was stuck here in Charlotte with a forecast, but I don't think they were ready for that. There was a lot of severe weather in the southeast last night, as you all know, and it not only affected a lot of flights, but affected a lot of people. This was a really rough outbreak in this area. Now, the map I've been talking about that over is one that's going to get me set up, I think, to discuss where this bigger picture pattern is going to continue to evolve. And we're really going to kind of follow up with what we talked about on Monday, an in-depth report on where I think this is going to go. So what's this map? It is the first 12 days of the year looking at average temperature ranks by climate district. So a lack of high amplitude flow, that's big troughs and ridges, really zonal jet stream as a result, has kept just a lot of mild air in place. There's been no big Greenland ridges or Alaskan ridges, and really nothing just to perturb the cold air that sets up over Siberia and the Arctic this time of year to have it come to North America. So it's been very mild. It's actually been quite wet, very humid in some places. And we've seen some impressive fogs throughout the northern plains of the United States, the upper Midwest, and parts of the Midwest. And this has really just been driven a lot by this pattern we're in, this mild pattern we're in, melting a lot of the snow and keeping the lower levels of the atmosphere saturated. Now, from here, I want to show you what that jet streams look like, just to review this. And to be honest, whenever we see the jet stream looking like this at this point in the year, this is a very El Nino-like view. In other words, these long stretches of high momentum flow coming across the Pacific, unbroken. That's something we often see when there is an El Nino going on. So it's interesting that we've just come off of a peak of our current La Nina, and immediately the atmosphere picked up several, subseasonal features to give us this. And we're going to talk about how those subseasonal features are changing, primarily with the MJO and stuff that's happening over and around Siberia, China, the Himalayan mountains, this particular area. On the precipitation side of it, as we all know, it's been extremely wet in California. You've got 2 climate reporting districts right now that are showing the wettest start to any year on record going back to 1893, and this continues right into this corridor. And a lot of this in Nebraska, South Dakota, and Minnesota is from that large winter storm we had earlier this year. Now, we've had plenty of rain on the Mississippi River, down in the lower and mid-Mississippi River Basin. We've been drier along the Gulf Coast down into Florida and quite dry along the coastal Carolinas, and there's pockets in New England that have missed out as well. The storm systems that are upcoming are going to continue to keep this area drier too, because they're going to come out of Colorado and hook pretty quickly like this into the eastern Great Lakes. So what this is doing is we don't have the right setup, primarily a big blocking ridge over Greenland and troughs that are digging down. They're digging, in other words, they press east rather than lift northeast to deliver a system that could run up the east coast and really soak this area. Now, one of the big things I want to talk about in this pattern in a few moments is how dry things have been in the southern plains and what that means going forward and what we might need to see in terms of correction here. So we've got quite a few things on the plate today to talk about. Here's where the front is this morning. It's finally cleared the coast, and we've got a lot of very low cloud behind this. A lot of this is even deep fog here in parts of the northern plains. But this is the tail end of that rough event yesterday that went through here. While this is going on, the sun's about to set about to rise as I'm recording this on the next of what will be 3. I believe there's 3 more strong onshore events coming into California. We'll have a look at those in a second as well. But just looking back over the last 3 days at total accumulated precipitation, while we watch this system kind of roll out and getting off the coast here, you can see kind of the streaks where these severe storms were. And the latest data from the Storm Prediction Center, and I included this in my morning report. Look, it's already up to 310 total reports now. 45 tornadoes in this part of central Alabama right in through here was one of the places where we saw this. We call it a QLCS. That's a quasi-linear convective system, QLCS. It had embedded circulations. It had a couple of supercells out ahead of it, and the environment was just ripe to get them to rotate. And the Storm Prediction Center nailed it. They called this whole area for enhanced risk yesterday, and it's certainly verified. It is a very rough go of it. We'll see how strong these tornadoes are as the survey reports come in, probably early next week. Now, since I want to keep this a bit more bigger picture about where this pattern is going to go, I want to reflect for a moment on this map. because it really just shows us what the last 30 days has looked like in terms of percent of normal precipitation. And I want to focus on one thing, because I think if we do that, we can start to diagnose how other pieces of this are going to change. And it's going to be the drought that's ongoing down here in the southern plains. Now, in this morning's brief report, I put the Nutrien Morning Minute. We showed the drought monitor, how it's changing, and we've seen some significant drought relief across the country. We've gone from a peak of about 86% back in November to now down to 66% of the land area in some form of drought. But it has stayed firmly anchored in this area. That's not to discount like other dry areas. It's just I want to talk about this one for a moment. So I went into Texas and I said, what might need to happen in January and February to recover some of this moisture before we get into the spring time period? So I reconstructed using one of my favorite tools. It's called Climate at a Glance. I chose the state tab, went down to precip 2 months, February, looked at the whole time series for Texas. I did put a trend on there from 1970 to present just to show you that the January-February precipitation trend is flat. No significant change here. It's volatile, but the trend is flat. And I then went down to the bottom feature, which I love. You can kind of change the rank of these. So you can say, what are the wettest years and what are the driest? So I plucked off all the wettest years and said, what would it take for the rest of January into February with respect to this pattern to deliver moisture to that area? And this is the big feature, okay? We need to get a trough of low pressure between Hawaii and Alaska. Deep trough here. That would then correspond to stronger onshore flow into California, but dipping down into the Baja, into Mexico. And if we can plant a ridge between the Great Lakes and the Hudson Bay, what happens is that the flow has to turn pretty hard around this. This is just the general flow. It doesn't look like this every day, but that's what has to happen. And therefore, lows, instead of coming out of Colorado, Wyoming, they come out of New Mexico. And they're able to draw Gulf of Mexico moisture back. That's it. So trough here. It also helps to have a bit of a higher of a low block in the North Atlantic. That's what we're going to be looking for. The second part of it is I took those same years, these are the wet ones, and said, what do the ocean temperatures look like? And they certainly don't look like they do now. It helps if there is an El Nino. And of course that makes sense, because when there's an El Nino, like I showed you earlier, you get more zonal jet stream flow. Whenever you have troughs here, the flow has to come very quickly around it, and that's more zonal flow in the Pacific. So those are the kind of things that need to take shape, and we are missing some of these components right now, which is why the likelihood going into January and February of relieving the drought in Texas is relatively low. Here's the other problem here. As we talked about, we still have La Nina, but it is, look at how much warmer the water is over here than it was in the past. In fact, I'd like to show you that. This is an animation. Let's let this reset here. This is an animation going back to October. Here it is, it's starting. And you're going to watch, this is when our La Nina was likely at its peak in November and December, right in through here. Now keep an eye here. We're in mid-December now. Watch what happens when we get to the start of the new year. So we do start to see some evidence that the La Nina is backing off. Even though we still have strong trade winds here, we are seeing other components of this beginning to fade. In other words, there's some warm water surfacing here. The Indian Ocean is no longer sending strong westerly wind bursts in this direction, and that's starting to move around several things. First of all, we've been talking about this quite a bit. We've seen the MJO spend a lot of time in null space, come out phase 4, 5, 6, 7, come crashing back in. 4, 5, 6, 7, 8, come crashing back in. We're now currently in phase 8, and there's some evidence that we're going to move this into the Indian Ocean. It's going to be weakly into the Indian Ocean, but that's important to understand, because if it moves into the Indian Ocean, we are missing another component we would need to relieve the drought in Texas in the southern plains. Because historically, if it's January or even into February and you're in phase 2 of the MJO, which is where we could be going, we tend to see more ridging here. The jet stream is retracted. Now, there's other reasons why the jet's going to retract in the near term, but this is one of them. And therefore, the flow comes in, comes over the top, and then dives down. This is a very common thing to see with a fading La Nina in January and February. And that's one of the reasons why we often see those winter graphics explaining what goes on during an El Nino winter, with a ridge here and a trough coming in here with a ridge out in the open Atlantic, maybe a broad one, the big Bermuda high stretching in through here. This is not a pattern that sets us up for brutal Arctic outbreaks. It is one that will bring in colder weather. I'll show you that in a few moments. But this is the pattern that we're going to go into, and it is certainly going to start to slow things down for the western United States. Here's what it looked like by day 10. Okay, remember, if we were going to see Texas go wet, there'd be a large, deep trough in this area. Instead, the flow's coming around like this, weakening here, running up into a ridge just off the west coast and then diving into a trough over the central and eastern United States. So you can imagine there's some colder air coming in through here. But this is also the wrong kind of setup to deliver a big East Coast cyclone event. We don't quite have the big downstream ridge that we would need. The position of the trough, because of where this ridge is just offset too much to deliver a big East Coast cyclone, which is why we're going to continue to see drier conditions along the coast for a little while. We'll talk more about that in a second. The other part of this is by day 10, here's our weakened jet. Now, it's actually quite strong, but its extent has been limited, and the flow splits up right in through here. Now, a lot of this occurred because of a large area of high pressure that was sitting here that has since actually I should draw that the other way. There we go. That was sitting here that has since broke off, pushed against the Himalayan mountains, and reduced some of our momentum that will eventually come out of the Pacific jet. You combine that with what MJO is doing, and those two features just suggest that we're going to limit the extent of the jet. So we go into kind of that feared pattern over the west, this high over low split flow right into this area. Things come back together from Texas through the mid-Atlantic. But again, when you see the jet stream like this, it looks good. You're like, okay, that'll get us some East Coast storms. But we don't have these two features in the right configuration to really crank things up the East Coast. It would also help if there's a big area of high pressure or a big ridge right there to go along with this. Now, with this jet retraction, we are going to see global momentum, which has been very high as of late, primarily driven right here. This goes back to the end of December up until present. That little feature of these warmer colors represents the extended Pacific jet. Well, when we lose it, the global momentum is going to drop. And we can already start to see that. I'm going to take you to, this is a professor at Northern Illinois University, named Dr. Victor Cassini. And one of the things he's graphing out here for us, let me take you down here, is this is his global relative atmospheric angular momentum. And you see how the values are low? So this is a forecast. What I just showed you is what's already happened, meaning that we expect the angular momentum to drop. And it's going to drop and probably stay lower for a while as the jet retracts. That's the feature we've lost. There was at once a whole lot greater speed and therefore more momentum, bringing this all the way across. So that's going to start to lose. At the same time, there's another event that's taking place that we need to watch. So we're kind of piecing together the three big things that are changing: the MJO, the retracted jet, and then this, the potential polar stratospheric vortex disruption that might be happening. So right now, when you look up there deep into the into the stratosphere, there's a bit of a warming event that's taking place. Sorry, it's right in here. It had been quite cold. We're starting to see things warm up, and we're starting to get some evidence. Oops, let's go here. There we go. Of a displacement. Now you're going to see that as I play this forward, because by the time we get through this weekend into early next week, we start to see the position of the polar vortex kind of have two sides to it, pushing in, squeezing it into two separate lobes. Now, sometimes it takes weeks for a polar vortex disruption in the stratosphere to completely connect with and link up with a tropospheric trough. And when that happens, we get really cold air. Where I think if this is going to be an effect on our longer term temperature patterns, I think it'll be in the central and eastern part of the United States, if and when it does happen. Until that time, though, we've got this going on. I apologize. We still have 3 more events coming into the west. And we're going to be watching 2 different lows in the near term kind of do something like this. And this particular pattern sets us up in the next 7 to 10 days where we still see drier conditions south. We'll have to see how well we return moisture to this area. It's drier along the Gulf Coast, and it's drier up this part of the East Coast, and this area, the Canadian Prairie into the Northern Plains, stays drier. After this, the whole pattern is going to completely flip back to a typical La Nina pattern, which I'll show you in a few moments. But what's interesting is when all of this jet stream split caused by the retracted jet, aided by the MJO, okay, when all that happens, we're going to lose the very, very warm signal we've had to start this year. So the next 5 days, looking at the GFS, this is very similar in the European model as well. It's still very mild. Some places here averaging over the next 5 days 10 to 18, maybe up to 20 degrees warmer than normal in parts of Ontario. And then you see the day 5 through 10, more mild air, but that split flow starting to introduce colder air here. Because remember, the split's just off the coast, so the flow's doing that. And bounce up into a ridge. This moves out soon. And the new day 10 through 15 is now starting to show some colder air coming back to the Canadian Prairie, coming out of the west, hitting the northern plains. And I think that the very end of this month is going to look much different than, of course, the way we started this month. The other part of this pattern change is what happens when we get out there past this week into week 2. So I kind of stopped there for a moment on the polar vortex side, but I want to get here. The GFS is quite different from the European in one area, this area right in through here. It is quite active coming out of the Tennessee Valley and up the East Coast. The European is the same. They're very consistent with the drier signals that we're seeing for the west. That's what the split flow will get us. But we need to keep an eye on this area because the newest European model run is drier in more locations with the wettest conditions really staying up the East Coast, but no big major winter storm currently in the forecast. The flow is going to start coming in like this and then turning. And that is just a different configuration than if the flow comes in like this and turns. It's much easier to draw on more warm, unstable air if you come into Colorado versus having the lows coming out of these clipper type systems that dive down like this. Now, before we go any further, you notice we are looking at a drier forecast for California. So let's just take stock of where we made it with the recent precipitation. I showed in this morning's video that Lake Oroville is up 100 feet from its lows back in early December. And right now that puts it at 88% of its historical average for this date. It's 47% full pool. That's up from about 28% full pool at the end of last fall. Shasta is up as well, so that's very good. I want to again just to reiterate something. Where we currently sit when you look at the average accumulation of precipitation for the northern Sierra, that's this area up here in California, we are well above average, okay? But we still are only about 2/3 of the way toward the total we would expect for this part of the water year. So that means we need to see what we just saw in the last 10 to 15 days happening again, but maybe spread out a bit more over the rest of January, February, March, and April. And then we'll be going into this next year with above average precipitation. I do not believe we have what it takes to come up here, 82, 83, 16, 17. And the reason is these were some of the strongest El Nino events in history that we have that helped drive this precipitation. So the issue right now is in the near term, after these next 3 events, this is probably going to pop up and then flatline. Now it did that last year about 15 days ago. But I don't have strong evidence to tell you that we're going to flatline all the way to April again. Okay? And the big change is we're going to be losing La Nina's influence going forward with time. So another thing I want to look at is snowpack because there's a lot of folks that have yet to see quite a bit of it. And this is a map looking at accumulated departure from normal. It goes up to 60 inches above normal and down to 60 inches below. I just tried to split the color bar evenly here. But it does start to highlight some areas that are in deficit. These are areas that have not seen much snow this year. Look at parts of Michigan, Eastern Corn Belt. Look at the Appalachian Mountains and then New England. We have yet to see that big either Miller B or Miller A type system that comes up and just dumps snow in New England. And the current pattern is not set up well for that. But we are above average in terms of snowpack for the West. I've shown you the NRCS data quite a bit. This is just another way of looking at it. So last 72 hours, again, this is what we've seen. And we've got quite a bit more on the way for the West Coast in the near term. Plus, we're going to talk about 2 systems that are run through the midsection of the United States. So let's pick it up here by going to the high-res NAM. We'll start this later on this afternoon, about 1 o'clock on Friday afternoon here. So scattered snow showers still in place here. I drove home last night with a lot of snow coming out of this. Didn't much stick around, but it was very heavy snow at times. And as we play it forward, a lot of snow that's going to be, snowflakes, that are going to be flying here in this section of the country up to parts of New England into Ontario. Now the next front does come into the west tonight, and you can see it there pushing into the west while the snow flurries and scattered snow showers push up against the Appalachian Mountains. But we're going to see another push right here on Saturday. That's event number 2 coming into the west. And that's one we're going to have to watch carefully because it's going to spread some decent snows into parts of Nevada, Utah, into Colorado, northern Arizona as well, after hitting California. And as it comes through, it's going to eject at some point early next week into southern Colorado. Now, snowfall totals out of these are still looking another 3 to 5 feet for the Sierra Nevada and the Klamath Mountains. And the Valley Range, we'll take a look at the rainfall totals in just a few seconds. But actually now, I had it next. We still expect to see 1 to 3 inches in parts of the Central Valley of California, more as you go farther north into the Sacramento Valley. You can see here in the Sierra Nevada that there's the potential for another 6 to 10 inches of liquid equivalent. Also very heavy here. We will see the trajectory of these storm systems shift to the northwest with time in this forecast, but a lot of what's going on here in parts of the Mid-South, the Ohio River Valley, the Tennessee Valley, is coming from two systems, and there is going to be a strong to severe thunderstorm threat in this area with them. But just take note that if the path of the lows is doing this is an area that sees weaker frontal passages. This is an area that deals with larger dry slots. We have no clipper systems in the near term, which is why we see the northern plains showing up as dry. Same thing for the Canadian Prairie. So let's do our multi-model analysis. The models are in pretty good agreement through this weekend. This is going into Saturday. That's the next wave coming into California here, Saturday into Sunday. And then they both, by the time we get into Sunday night and Monday morning, eject a low somewhere out here into Kansas. Now, as that low comes out into Kansas, we have our third onshore event coming into California here on Monday. And I just want to make a point that possibly on Monday night, let's leave it right here, we just want to keep an eye on this area for the risk of some stronger storms. Just we could see that in this region. I know a lot of folks lately have seen quite a bit of lightning and thunder in January. And I know there's an old saying that if you got that lightning and thunder in January, then you're going to see good rains in June. I'm going to talk about that in the next few videos. I think I'm going to do a little bit of research into getting that answered. But at this point, just to come back to the forecast, there's not a lot of cold air in this to really deliver a big time snow on the northern side of this one. But good model agreement. I mean, this is really solid model agreement through Monday evening. As we go out here into Tuesday, one low exits. And we're going to keep an eye on the next low that comes out here. Now, as is normal, the GFS is quicker, more progressive. The European is a bit slower and has a larger area in the backside of snow. Also, next Wednesday night, both models, we need to keep an eye on the Mid-South down to the lower Mississippi River Valley for more strong to severe storms. That is actually in both models, even though the GFS is quicker. Now, that low heads on out. See that? And if you watch as I rock back and forth, this is where the transition to where the flow comes in the northwest begins. See that? So coming into Oregon, Washington, Idaho, we got another system coming in next, Tuesday, Wednesday, Thursday as one exits. And California is now out of the stronger flow. Now, once we get out there toward the end of these two operational runs, they diverge in a big way. The GFS, remember I showed you the GFS wanted to put wetter conditions here fully out into week 2? That's because it's trying to kick off another like Red River Valley of the South low or an Arclitex low, which is nowhere to be found in the European. Watch the European. See what it wants to do? It wants to kick off a clipper system that comes down. And that's not in the GFS. So very interesting differences once you get out there past about day 8. But if we put it all together and just look at some of the maps, I put these in the morning report as well, just kind of highlights who's going to be wet and who's going to be dry. On the right, the probability of less than 1/10 of an inch. That's on the left. On the left, the probability of 1/10 of an inch or less. So again, we stay quite dry in Texas and parts of the plains. And then you go into the right, you have the probability of being wetter, more than an inch. And that really just identifies that Tennessee Valley, Ohio Valley, New England corridor for these next few systems. Okay, finally, just want to make a brief note about the snow. The snow that will be coming into the Four Corner states, the central northern Rockies, and then the Sierra Nevada mountains, they're going to be huge. We still have a lot more snow that's going to get added up into this area, which means it'll be important next week to get a full tally on what this winter's delivered so far. Just with that system coming out on like January 18th and 19th, we still see the models picking up from Colorado through Kansas, parts of Missouri, Iowa, Illinois, Indiana, northern Indiana really, but Michigan and Wisconsin, southern Minnesota. That's an area we're going to watch as well for some decent snowfall possibilities. Okay, I want to switch back to a longer term view now, and I want to talk about how quickly the models are suggesting El Nino comes back. So you notice here that they are trying, the European especially, is trying to go full INSO neutral by the time we get into, February? By March, 0. By April and May. I mean, we only need to be a ½ degree above normal to be considered El Nino. And then they're going full on El Nino by the time we get into, late spring, early summer. Now, I just want to make a point. There's only been really one time in recent memory that we've been able to make a transition that fast. And the time that happened, it wasn't even really quite as strong as of a La Nina we have now. It was what happened when we had arguably our second strongest El Nino event on record that happened coming out of starting in 1997, going into early 1998. If you notice, this is January 1997 to January 1998. That's what these faint lines mean. And we were rapidly building, reaching a peak in summer, our El Nino. Now, normally what happens is the transition's a bit slower, and it typically takes all the way until you get into the next fall or winter that the El Nino really shows up. And given that this is a very odd, I mean, when I say odd, just mean unprecedented look at 3 years of La Nina. In other words, we didn't have any big breaks in between here. I don't know that this one's going to transition as fast as the models suggest. But we did get some new information that does, I think, help with that. And this was just released yesterday. It is from the Climate Prediction Center, but it's out of Columbia University. And what they show is they've reduced the likelihood in February, March, and April of having INSO-neutral conditions. It was over 80%. They've now pushed that into March, April, and May. So they're kind of pushing this out a bit. And they're showing the development of an El Nino here in the red, but really not outpacing the neutral conditions until probably late summer and fall. And I think this is a good, solid forecast. So I just want to talk about the timing of this. Now, what's the big picture meaning of all of this? When you get rid of a La Nina for North America, it tends to mean that we give the jet stream back some of the momentum that it lost when there was a La Nina. So historically, we would say this is better. We would just see better precipitation for the country. Now, that doesn't mean there won't be regional drought development. No way. I'm just saying we've taken off the table one of our major threats to drought development, which is La Nina. All right? That's what's really going on here. So I want to take you back to some other forecasts for February, March, and April. And I'm really finding myself siding with the CPC's outlook. And what it shows is probably keeping more of that split flow around at times. I think California does better once we get into mid to late February, March, and April. But the problem is going to be with all of this is that we are yet to fully develop the big El Nino pattern to deliver the deep troughs between Hawaii and Alaska. I mean, that's the first thing we talked about, right? Where was that slide? Somewhere in here. That pattern. Okay, are we going to get here? I don't think so. And as a result, this is going to be an area that we may have to wait until spring until we see substantial drought relief, primarily a little bit farther to the south, this area and through here. But I think this is going to be active. I think that this area will see at some point later this winter better chances at returning moisture. But I tend to side with this as the mid to late winter outlook for February, March, and April. All right, so let's just keep that in mind because next week we'll have new long-range data from Columbia University to add on top of this. Okay, I want to finish with South America. I pulled up some of the new NDVI imagery. This was just updated for Cordoba, Buenos Aires, and Santa Fe. And we are still almost at the very bottom of the 20-year average here. So it shows us the stresses that have happened. Now, there have been some pop-up thunderstorms that have hit some fields and helped provide relief. But looking at this a few different ways, the newest GRACE root zone soil moisture map, there we go, let's bring that one up, continues to show just the exceptional drought that is in this area down here in parts of Argentina and in southern Brazil, specifically Rio Grande do Sul. Now, Rio Grande do Sul grows a lot of full season corn down here, plus soybeans, and the quality of that crop has been jeopardized by how dry things have been. And of course, we've been discussing a lot about Argentina. I want to show you a couple other things. We looked at this a few weeks ago. Let's see if I can blow this up. There we go. This is for Buenos Aires province. We're looking at the area that grows soybeans and the Vegetation Health Index computing here to look at the percent of drought area. That's what we're using. So again, you go back 10 years, and this has been the widest spread and deepest in extent drought we've seen. We can flip this over to Cordoba. Let's see if this will happen quickly. And when we go to Cordoba, oops, maybe the website's freezing up on me here, but I'll tell you, you're going to see very similar thing. Hopefully it'll update. Oh, it did. I'm so sorry. So here you go. You can see in Cordoba how extensive the drought area is. I apologize for that. So this is something that's going to continue to be an issue. Now, what's going on in the near term? I'm going to use the 0Z Euro to kind of show you this. You're going to see a lot of precipitation in southern and central Brazil. You're going to see decent rainfall as I go through the next week. That's going to return to Rio Grande do Sul, an area that desperately needs it. But look at this hole. This is Santa Fe, this is Cordoba, and that's Buenos Aires. Stays hot, as it's the middle of summer down here, and all the way through the next 7 days, nothing. Better rains everywhere else, almost, except this area. Big hole there. The models want to, watch this is way out there next weekend, wants to fill it in. But we've seen the models do that time and time again, and it never did it. It just doesn't fill in. So the bigger picture is you look over the next 15 days, Little drier in Mato Grosso, still plenty of precip here, but good for harvest. Very wet as the crop tries to finish. Some of it tries to finish here in central and southern and eastern Brazil. Better rains into into Rio Grande do Sul, but this is the area we're going to continue to watch and worry about in Argentina. Okay, I appreciate, again, the extra time to get this out to you. Have a good rest of your weekend, and we'll talk again next week. Thanks.